All right, to recap what we just said for part A, if you integrate a rate, which is what you're given, you get an to find the total amount from 0 to 20. We integrated the rate. You used a calculator for this. Came out to be 1,654 cars. Okay. All right, next up, letter B. Is the flow of traffic increasing or decreasing? Don't overread things. Go all the way back to the beginning of the year. What type of math, what type of setup, what kind of problem did we do if they asked you is something increasing or decreasing? What did we do? What kind of test?
Finding the velocity and acceleration in
No, this doesn't say is it speeding up or slowing down. It just says
A first derivative test?
yeah. So we're talking about a first derivative test of sorts, but now we have a very specific place they're asking us to figure out. So when you did a first derivative test, that was like, well, tell me about the whole function. Tell me where it's going up and down and all around. This one's just saying what's happening at 5. So all we want to do is find f prime of 5. So we have f of t. So is the flow of traffic increasing or decreasing at 5? We're just looking for f prime of 5. And somebody tell me what that is. If you didn't do it to begin with, do it right now. Go find f prime of 5 using your calculator. When somebody gets it, let me know.
I got a negative answer.
All right, what'd you get for an actual answer?
Negative 1.6022.
All right, f prime of 5 is equal to negative 1.602, which is less than 0. Therefore, what? We want to rate a conclusion. Therefore, traffic flow is decreasing at t equals 5. Does that make sense, guys?
Yep.
Okay. And what do we got here? We got a part C. What's the average value of the traffic flow over the first 15 minutes? So should be pretty straightforward. That's going to be first 15 is 0 to 15. 1 over b minus a is 1/15th, and then times the result of the integral. And you're doing all of that in your calculator. So somebody that did that with the 1/15th out front, etc. Tell me what you got.
I got 82.348.
82.348.
And then since it's average value, would you say like cars per minute?
Yes. So
Okay.
82 point. Does it give us any rounding directions? Indicate units of measurement?
No, it didn't say.
So 82. This one's not an actual free response from a previous problem. This is one that I think me and Mr. Nickley made up over the years. So this is not like an official one. Yours would have a little more direction to it. So it would be 82 or 82.348, depending on the directions. Cars per minute on average over 0 to t to 15, something like that. Anything that's explaining it's the average cars over the first 15 minutes would be getting you guys credit there. So, oh, and there's a D, sorry. What do we have for part D? What is the average rate of change of the traffic flow over the first 15 minutes? Indicate the units of measure. All right, now, the average rate of change of the traffic flow. What are we thinking here?
derivative?
So this is where it gets a little
Slope.
confusing. It's, say again.
I said the regular. Should we be looking for the regular slope?
Yeah, so let me make a rule here for you guys, because we use average value for everything. Average anything is always 1 over b minus a times the result. Now, when they ask for average rate of change, though, that's the exception to the rule for us. Average rate of change is just going to be, let's find the slope. Okay. So as far as this question is concerned, it was asking you for the average rate of change. You're still finding the average rate of change when you do this, but this one takes you backwards. It's confusing to understand what's going on here. So like if I ask for the average velocity and I have an equation for velocity, it takes me backwards one, so that whenever I'm still finding that regular slope. But when it says the average rate of change, that's like us saying we need to just use the original. So average anything is 1 over b minus a times the result, except average rate of change. Let's just do regular old slope. And let's see what we get for that. They tell us to do regular old slope over the first 15 minutes. So that's going to be 0 comma something, 15 comma something. You use the calculator to go figure out the somethings that would correspond. So my best guess or my best advice would be to graph that and then trace it to 0 and trace it to 15. So let's take a second and have you do that and tell me the points that correspond with 0 and 15. Anybody got corresponding points for me for 0 and 15?
For 0, I have 82, and for 15, I have 85.752.
Okay, and then you would just use those and we would find the slope. So this would be 85.752 minus 82 over 15 minus 0. And you should actually be able to just leave your answer like that because it's free response. But you would get something equivalent if you typed it in. So does anybody have any questions on ABCD? Does that plan, those processes make sense?
Wait,
Makes
I
sense.
82.5 for 15.
Say that again, buddy.
I got 82.5 for 15, so
Oh, I might have, I did this morning, so I might have accidentally wrote it down wrong.
yeah,
What'd you get? 82 what?
0.5.
Okay. Either way, so we got the right idea here. We got the gist. You would type the big idea. The big thing is that you have the idea down. So does anybody have any questions on the ideas of this problem? All right, sounds good. Moving along. Next one. I think we've done this next one already, if I'm correct. This is the one where the temperature was decreasing. So we're just going to go quick through this one. Use the data in the table to approximate. What are we doing for part A? What's the plan?
Taking the slope.
Finding the slope, and since they asked you for 3.5, you would use these ordered pairs right there. Does everybody agree? So we would say the
It's
time
negative
is changing. Yeah, it's gonna be -8/3, right? And then that would be degrees Celsius per minute squared. Okay. All right, what's going on in part B? What's the meaning of this?
The average time it takes between 1 minute to 10 minutes for the pot of tea to cool down.
How about just average temperature over the time from 0 to 10?
Yeah, that makes more sense.
Does that make it easier? Yeah, keep your explanations as simple as we can. Average value. So what are we talking about? Average temperature. Just like if you can in one word summarize what this stands for. It stands for temperature. So average temperature over the interval. Okay, and then use a trapezoidal sum. Shouldn't have any trouble with that. The trapezoidal sum is what you use to approximate that piece right there. And then you have a 1/10 out in front of it. And then with that, you would get your answer. Okay. Next, what are we doing for part C? Evaluate H prime. What's in the box?
Integrate.
Oh, we're definitely going to integrate. Yeah, what's in the box though? H prime or H?
H prime, and we takes us back to H.
And that's what's, and what I was saying is in the box is H. So this is FTC. If you integrate H prime, we don't have a formula for that. So I don't have anything that I can punch in the calculator, right? So all I can do is say that if I integrate H prime, what am I going to get? H prime of t
10 negative H0.
is going to be H of 10 minus H of 0. And then you can go right into the table to grab H of 10 and H of 0. What is that going to give me, guys? H of 10 is what?
23.
43.
And H of 0 is
66.
6. So that integral is equal to what? -23?
Yes.
Okay. And what are we talking about here? We integrated H prime. So that's the total what? Total degrees
Cooled.
cooled. Yeah, try to repeat the time interval. Total degrees cooled over 0 to t to 10. Okay, let's tackle part D because that's a mess. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from the oven. The temperature of the biscuits at time t is modeled by the function b, for which it's known that we've got b prime. Okay, we've got b prime, some mess of a formula, whatever. It's calculator question, so that's okay. We have b prime. Using the given models at t equals 10, how much cooler are the biscuits than the tea? All right, this one's a little crazy. How did t get involved in this? What do we know about the t at time equals 10?
It's 43 degrees Celsius.
Okay, so keep that off to the side in your mind for a while. At t equals 10, the t is 43. We know that. Now the question says, how much cooler are the biscuits? So in other words, go find the temperature of the biscuits at t equals 10, and then compare that answer to the number 43. All right, so let's read again. At t equals 0, what are they giving me right here?
The derivative.
No, on this part right here.
Yeah, the biscuit, the original temperature.
They're giving me that piece of information. This is the extra piece of information you need to do FTC. Okay, that's the extra piece of information. At t equals 0, the biscuits have a temperature of 100 degrees. Okay, just keep that in mind. Temperature of the biscuits at any time. All right, they want to know the temperature of the biscuits at what time? T equals
10.
So does it make sense to say that if we integrate b prime of t from a bound and a bound, one bound I know and one bound I want, what am I going to get when I integrate this?
B of 10, like the temperature of 10.
B of 10 minus b of 0. But what is b of 0?
100.
Got it. All you need to do now is we're going to add this 100 over. So now it's 100 plus, you guys head to the calculator and figure out that interval for me. Oop, that's 0 to 10, not 100.
That's negative 65.817.
Say that again. What is it?
Negative 65.817.
Okay. All right. Now, what do we do with that? What do we get for an actual answer?
34 point something.
What's the something?
I don't know.
34 point, what would that be? 183?
183.
Okay. Okay, now what did I just find? What is that? That's the temperature of the what at 10?
The biscuits.
And what's the question asked me? Compare it to.
How much cooler it is than the tea.
The
Subtract.
T is 43. The biscuits are 34.183. So what's my actual answer here? The biscuits are what? 8 something?
8.817.
8.817 degrees cooler than the T at T equals 10. If that's making sense, guys, you're going to pass the AP exam. I have good news to tell you. That's pretty in-depth. So do we have any questions, comments? Does that make sense? What do you think?
Mr. Baker, I did it this way. I integrate the derived function that's given for biscuits.
Yep.
I subtracted from 43. Like, what is the problem in that?
What do you mean you subtracted it from 43?
To get the difference, like.
Oh, you say you integrated this?
Yeah.
Okay, and then what happened? What'd you do after that? So that's
Yeah.
what, 65 something.
Yeah, 65. And I subtracted it from 43. But
Where'd you get 43 at? Oh,
that's the temperature of the teapot.
that didn't give you the right answer though.
No, it did not give me.
Well, because the 65.817, that's not the temperature of the biscuits at T equals 10. You got to solve for B at 10 to get that answer. Remember, when you integrate this, it gives me the temperature at 10 minus the temperature at 0. So to solve for the temperature at 10, this right here, I'll put a box around it. This blue box stands for the temperature of the biscuits at T equals 10. This is just one piece of the puzzle that takes you there.
Okay.
So then you got to combine it with that 100. And then when you do that, now you've solved for B at 10, which is the temperature of the biscuits at 10.
Yeah, I thought I would like go back and find the original form of the biscuits equation, like not the original form of.
Now, yeah. Now the thing is that if you actually integrated the equation, not that you're not, you are, but you're just getting like a numerical answer. If you actually integrated the formula, and got a real formula, like if you went from x squared, and then you told me that was x to the third over 3, and this was really going from B prime to B, and then you knew that was B, then you could sit there and just toss in a 10 there and you're fine.
Yeah,
but when you go with FTC and we integrate B prime and get B at 10 minus B at 0, nowhere in that setup did anybody ever tell me what the original equation B is. This is just like a calculus trick for backtracking into an answer if you can figure out everything else but one thing.
Oh, okay.
Does that make sense?
Yeah. Thank you.
Give me 1 second, guys. Hang on. Okay, so any other questions there? All right, moving on. All right, next up. I'm thinking we don't got to do much with this one, right? Part A, you should be good. Part B, show there's a coordinate P where, what are we finding here? It's a horizontal tangent. Horizontal tangent means set the top of the derivative to 0. It also goes on to tell you, oh, by the way, x is 3. So the plan for part B would be to find the horizontal tangent by setting the top of the derivative to 0 and also letting x be equal to 3. Any questions on that? Then part C is just find your second derivative quotient rule, use your dy dx value, et cetera, et cetera. We've done that a lot. Everybody good with this one?
Yeah.
All right. I'm not going to lie to you guys. I didn't do this test this year. I normally take it every year myself. So I haven't done it yet. So you guys tell me the answer. And if we have a strong disagreement, we will go over it. So what'd you get for number 1?
D.
Anybody disagree? Okay. About number 2, and or if you want to see any one of them, just say that and we will pause and go over it. What we got for number 2, Leela?
I did not finish this bit.
All right, fair enough. Syed, you got anything here?
I just did the last
First.
2. Yeah,
All right,
yeah.
so we just skipped these because we knew what we were doing. Is that
Yeah,
the case?
very- yeah.
Yeah.
Okay.
Mr. Baker,
Yes, sir.
can you explain like the different answer choices? Because like it's the format, if that makes any sense.
For number 2,
For number 2, yeah.
what'd you get for an answer?
I put E, but like I did the work, but I didn't know how to write it out.
All right, hang on, let's get to a problem. 5x to the 4th minus 24x to the 3rd. Okay, first things first, you did 2 derivatives, correct?
Yes, that's correct.
All right, so first derivative is 20x to the 3rd minus 72x squared plus 48x. Constant's gone. Let's take a second derivative, so that would be 60x squared minus 144x plus 48. Okay, we're going to set this to 0. We can take out a 12 to make this easier, and then that would give me 5x squared minus 12x plus 4. Okay, we're going to factor this, so that would be 5x and x, and looks like 2 and 2 is a winner. That would be 10, 12, yeah. This is what you got? You still good?
Yeah, I got that.
Okay, so we got 2/5. We got 2, so we're going to put these on a line. So here's 2, here's 2/5. We need to pick stuff around it. So we've got 10, we've got 1. I'm going to go with 0 because I never get to use it. That makes it easy to plug in. Plug this stuff into the second derivative. If we plug this in, here's my second derivative. If I plug in 0, what'd you get for symbols?
Plus, minus, plus.
All right, let's see if we agree here. Plug in 0, definitely get that. Get that. Yeah, I agree. Okay, what'd the question ask?
Where is it concave down?
Concave down. So we're looking from negative, we're looking from 2/5 to 2, right?
Yeah.
All right, so now let's go back to the choices and see what we're talking about. We're looking to go from 2/5 to 2. All right, so you should be comfortable ruling out A and B. Agreed?
Yeah, I agree.
All right, now how do I show? Now I want bigger than 2/5, less than 2. All right, so bigger than 2/5, less than 2. All right, so you see how this one's talking about -2/5, so we're good ruling that one out too, right?
Yeah.
Okay, now we're down to D and E. We want between 2/5 and 2. See how this one said, this one says X is greater than 2.
Yeah, when it's less than 2.
Yeah, it's less than 2, right? And this one says less than 2/5. So we want greater than 2/5, but less than 2. So that's what this one down here is saying. So to read that, just read one piece at a time. So in other words, cover this part up. You don't see this. The part that I highlighted, though, does that make sense to say X is greater than 2/5?
Yeah, that makes sense.
And then this part over here now, cover the other side up. That's X is less than 2. So just kind of cover each half up, and then you should be able to find the answer that you're looking for.
Okay, thank you.
Mr. Baker, what I do, I don't know if this might help Caleb as well, is just write down what I get, and then I don't even look at the answer choices because sometimes they're purposely confusing, and then use what I got for the answers, because I know also for the
This is
SAT.
multiple choice though. So hold on here. How do we get the right answer doing that?
No, I mean, like, for example, I write down my answer, and my answer is
So what's your
2 over
answer?
5. For this question, 2 over 5, and then is less than X, and then X is less than 2. So you
Okay.
get that right. And then based on that, you eliminate the answers. Because if you just look at the answers first, sometimes it can throw you off.
Oh, yeah, that makes sense. Yeah, that makes sense. Okay. Yeah, good. Any questions, guys, on that one? Okay, we ought to be good on number 3, right? Tangent line problem. You could have done that ages ago. Yeah, let's do 4 and 5 because you'll see this question on the exam and it's going to be easy and you're going to get it right. 4 and 5, use the graph below. Spider begins to crawl up a vertical blade of grass at t equals 0. The velocity of the spider is given above. So we're looking at the velocity graph. When's the spider change directions? Instead of a particle, they put a spider. Who cares? When's the spider or when's the particle change directions?
At 4.
Yeah, at 4. This is the same exact thing as particle motion. They just renamed the particle a spider. It's the same thing. When does the spider change directions? It would be at the turnaround spot, would be at the 0 of the velocity graph. 5. What's the total distance traveled of the spider? Ooh, I like that one. All right, total distance traveled. How do we find that, guys?
You take the integral, so, or you could just like find the value, but then I'm pretty sure it's the positive. I mean the absolute value of it.
Right. So total distance traveled. Now, I don't have a formula to integrate, Leela. So what am I doing here to figure out my integral? I'm going to have
You're
to do
just
what?
gonna have to manually find the areas of all
Yeah,
the
so
triangles.
exactly,
stuff.
guys. So we want to find the area of everything up here and everything down here. And now normally we had said any shape that's above is going to be positive. Any shape that's below, it would be negative. But since we're asking for total distance traveled, you're going to ignore that because it's absolute value. You're just going to keep everything positive and then get whatever you're supposed to get from there. Does anybody have any questions on that? 4 and 5, all but guaranteed you would see that on your AP exam. Okay. 6, are we okay with area bounded?
Yeah.
Okay. Anybody have any MVT problems? Okay. So I'm cool if you're not doing some of these guys, but just make sure you know them if you're not doing them. Just be honest. If you need to practice any of this, got to make sure you know the old stuff. Any problems on 8? Talking about extrema and points of inflection. It's talking about do a first and second derivative test and then crank out all the answers and see what's what.
Yes, makes sense.
Okay. 9, particle. A particle's velocity is shown below. Let's do number 9, everybody. Use this function to state the time where the particle's traveling to the left. Now that we've done lots of particle motion, this is just by hand, but now that we've done some of these, tell me what's going on here. We're looking to figure out what, where via t is what?
Is it positive or negative? And also the
Well, yeah, we're gonna do a test on this, but which one is gonna be the answer to my question? It says the thing's moving to the left. So
Negative.
I want to know where the velocity is negative, right? So you want to find the velocity, which good for you, they've already given it to you. So I'm just going to set it equal to 0 and do a derivative test with it. Set the velocity equal to 0, and then let's test it out. So v of t is equal to sine pi over 2t. Okay, and it's from 0 to 4. From 0 to 4, those are your walls, 0 to 4. So use this and solve, see what you get. Okay, so somebody walk me through this. If we set this equal to 0, what's going on? Somebody.
You could divide by the is it the pi squared in t?
Not yet. How do we solve a trig equation? I'm about to teach you some pre-calc next week. How do we solve a trig equation?
Where the sine becomes
Yeah, we cover up the angle, and then we ask where is sine equal to 0? And it should be at 0, pi, 2 pi. Then I uncover what I had covered up. Pi over 2t is 0. Pi over 2t is pi. Pi over 2t is 2 pi. Now we solve for each one. How do we solve for each one? By
like dividing, for example, the first part by 2 over pi.
yeah, how about we just multiply it by 2 over pi?
Yeah.
That'll do it, right? So multiply by 2 over pi. So that would cancel. So what do we get? T equals 0. If we multiply by 2 over pi, t equals 2. T equals 4. Those are my critical points. So I should test them. Remember, the graph said that at 0 and 4, we had walls. So this is a wall. This is a wall. What are we picking for test values?
3 and
How
1.
about 1 and 3?
Yep, better be 1 and 3. We don't get many other choices. All right, first derivative test gets plugged into the first derivative. The first derivative is velocity. So all we do now is just go up here and plug these in. If I plug a 1 in for sine of pi over 2t, that's sine of pi over 2. Sine of pi over 2 is positive. If I do this for 3, sine of 3 pi over 2 is negative. The question asked, when is the velocity going to the left? How do we figure that out? We want to know when the velocity is negative. The particle or velocity or whatever it is they're talking about in this question is going to the left from 2 to t to 4. And if it's a multiple choice, you're done. If it's free response, it's because v at t is less than 0 on this interval.
Mr. Baker,
Yes.
you plug in the 3, it's going to be sine of 3 pi over 2 is 120, right? And that's in the second.
Sine of 3 pi over 2 is 270.
Oh yeah, that's.
You're thinking 2 pi. You're thinking 2 pi over 3.
Yeah, sorry.
All good. Okay, let's see what else we got. Number 10, shouldn't have any trouble there. Factor cancel, get an answer. All right, let's have some fun and tackle this problem, see what we get. Bonus worth 1% if we had a real grade. All right, the rate, as soon as you hear rates, should pop into your mind. Well, if I integrate this, it'll give me an amount. The rate at which water flows into a drain pipe. You can stop right there before you can keep going. What kind of problem is this? How have I described this problem? I said you'll see a bunch of these. What kind of problem is this?
The first derivative test.
Oh, maybe. I'm just saying, what's my name for this free response? This is an in and an out problem. Something's coming in, something's coming out. Remember, I always told you you're going to have either water, or bananas, or customers, or something going in, something's going out. And when you identify that that's what you're working with, gives you a little bit of a head start. So I just see that rainwater's going in, and I've got a formula for that. Okay. And then I see that it's for 0 to 8. Okay. The pipe is partially blocked, allowing water to drain out the other end. So now I have a formula for water going out. R at T is in, D at T is out. And then they give me the bonus piece of information. At T equals 0, my problem starts with 30 cubic feet of water. So we've got 3 major pieces to the puzzle. I have a formula for in, I have a formula for out, and I have something there at the beginning of the story. All right, now I'm going to have you guys do this problem for homework, but I want to read it with you first. All right, for part A, how many cubic feet of rainwater flow into the pipe for 0 to 8? That is a total amount. You have a formula for what the rate at which water goes in. I want the total amount of water that goes in. And this is a calculator question. Part A is very easy. Part B is the amount of water in the pipe increasing or decreasing at T equals 3. Remember what I've been telling you guys. The more of these you do, the more you'll see the same exact question, just worded differently. Here's my point. Here's the car problem. What they ask in part B of the car problem? Is the rate of traffic or is the flow of traffic increasing or decreasing? How did we do that? We did a derivative test. We said, well, what's f prime of 5? Is it positive or negative? Looks a whole lot similar to part B in this one. Is the amount of water increasing or decreasing? Now, what's different about this? Do we have a formula for amount of water?
Yes.
What's the formula for amount of water in the pipe?
D of T.
Is it D of T?
What's D at T stand for? What's it tell you?
That's how much is coming out of the pipe.
That's how much coming out of the pipe. I want to know that is the amount of water in this pipe, when I put the whole story together, is it increasing or decreasing at any given time there?
So would it be R of T minus D of T?
Getting warmer, getting much, much, much warmer. What other thing are you forgetting about?
Oh, it has to do with that.
What about it?
From a boundary now to a bounds.
Nah, that's a good idea too. But now, what's in the beginning? There's just something in the pipe, right? So if I'm going to integrate, I want to know how much water's in this thing, right? So I want a formula for amount. So recap for me what you know about this problem. What do we know? Tell me what
Okay,
we know.
so it's R of t minus D of t, but then is it plus 30 because there was already 30 there?
Yeah, exactly. So if R, I want a formula for amount, and then we know that at t equals 0, dot, 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 we got 30. So I need an amount formula. So the amount formula, first off, if I'm going to figure out if it's increasing or decreasing, you're going to have to take the derivative of it. But first off, I got to make it. The amount formula would be 30 plus 0 to t r of t dt minus 0 to t d of t dt. Does that make sense that that tells me the amount of water at any given time? Like if I plug in 5, that's going to tell me how much water is in there, right? That's the total amount in. That's the total amount out. That's how much is in there at the beginning of this story. Now it asks me, is this amount increasing or decreasing at t equals whatever? So what would happen if I took the derivative of that equation up above? Somebody quickly derive it.
You'd have to do a lot of the FTC stuff.
Oh, you don't have to do anything. You're overthinking.
What?
You're
Oh, good.
overthinking. You're overthinking. But what happens to the 30?
Oh, it goes away.
Okay. What happens if I derive an integral?
It's just the thing.
Okay. That's the derivative. And then on, look, what did it say in the question? A prime, or what time are we caring about?
3.
So now you would go into the calculator and figure out R of 3, and you would figure out D of 3. And if you get a positive answer, the thing's increasing. If you get a negative answer, the thing is decreasing. All right, that's more than I wanted to tell you for that one, but now you should be on the same page, hopefully. All right, let's talk about C. At what time is, you're not going to know how to do C. I got to teach you C tomorrow. And the pipe can hold 50 cubic feet of water. You can do D. So I want you guys for tomorrow to spend no more than 20 minutes on A, B, and D. And if you want, take a guess there on C. Think about absolute extrema. What is absolute extrema?
First derivative test.
Absolute extrema. It's been a while. First derivative test gives you relative extrema. What was absolute extrema?
Isn't that where you had to like plug in the zeros and then you had to do something? I forget. But
Endpoints and critical points into the original. Get ready to repeat that 100 times over the next 2 months. These free response problems will start using absolute extrema. Endpoints and critical points go into the original. So we're going to be spending a pretty good amount of time on this problem tomorrow night, because I need to make sure you guys really, really, really understand this problem inside and out. So spend 20 minutes tonight on this one and familiarize yourself with it. Try it in your calculator, try to do your best with it. And then we're going to spend a fair amount of time tomorrow on this problem. Okay. Do you guys have any questions?
On C or D or
On anything you want.
okay.
All right, guys, give me 1 second to scribble some names down here for attendance, and we will be out of here. Do you guys go back next week, or is it the week after?
it's the 16th, I think, is the first day.
Is that for everybody?
I think it's like they do it by last names. So like since my last name's a T, I go on Thursdays and Fridays, but I think it's people who have like A through L go on Mondays. I mean, not Mondays, Tuesdays and Wednesdays.
Okay, and that's starting on the 16th, is that right?
Yeah.
Well, I will be exonerated from going back to school because my name starts with S. Oh, that's the last name.
All right, guys, good job. Spend 20 minutes or so on this last problem so we have something to talk about tomorrow and you're familiar with it. I will see you guys tomorrow either at 3:30 or 7:30. So have a good night.
There were, Mr. Baker, there were a couple of questions in the chat.
Oh, I'm sorry, I missed that. Let me see. What do we got in chat? Have you heard anything about the AP exam? Is it going to be in person? How's this class going to work when we go back? I do not know a final answer, Jessica. I believe it's going to be in person, and I believe it's going to be on May 24th. That is not official though, but May 24th is the day that I proposed or sent in as my feedback for when I wanted it. The options were May 4th, May 24th, or some crazy date in June, and June was way too far away. So as far as I could see, it was just like 2 weeks difference. So I just got you guys 2 more weeks to study. I think it's going to be in person, but I don't know that yet. And I'm sure, given everything that's going on, there will be an online option probably. I don't know that though. Cade, how is this going to work when we go back? I don't have the slightest clue. My guess is that this 3:30 class. So let me ask you that then, since I got some of you guys here. How can you guys make 7:30? Like if you had to?
Yeah.
Is there anybody in here that like absolutely couldn't make 7:30 if push came to shove?
I couldn't. I have stuff going on every day.
Okay. Anybody else fall into that category? That's a no. Jessica says no.
Yeah, same.
My guess is that there's not going to be a 3:30 class anymore because there's no way that you guys are going to be able to get to it in time. So my guess is it's either going to be a 7:30 class or the videos from Bennett will be posted still. But I don't know that yet either. We will see what happens in 2 weeks when we go back. Okay.
Mr. Baker,
Yeah.
with the AP exam, I don't know if like you followed them on Instagram, but, like they College Board had posted something about it, and they were like online. They were planning to have like a full 3-hour test.
Yes.
For like all of the classes.
Yeah, I believe that's going to be an option. I believe the school's going to offer it in person on May 24th, and I'm pretty sure that's what they're going to be pushing. But I'm sure there will be an online feature available as well. So we'll know more as we get there, but they're starting to hammer it out. Okay. All right, guys, have a good night. I will see you tomorrow.
Thank you, Mr. Baker.
You're welcome.